Today's section is section 10.4, inscribed angles and polygons. So we're going to be using inscribed angles of circles. Our first topic is inscribed angle. An inscribed angle is an angle whose vertex is on the circle. Big thing is that the vertex has to be on the circle. The intercepted arc is the arc that is between the sides of the inscribed angle. So if we look here, we have an angle, this arc right here is the inscribed arc. One thing to note about the inscribed angle and the intercepted arc is that the measure of the angle equals 1/2 the measure of the arc. So for example, if this arc were, say, 40 degrees, the angle here would be half of that, would be 20 degrees. On this diagram, we're asked to find each measure below. Our first one here is EA. So we know that 40 equals half of the arc. Multiply both sides by 2, and we get that EA is 80 degrees. When asked to try and find ED, we know that the chord through the center is a diameter, so we're going to take 180 degrees for the semicircle minus the 80 from EA, and we find that ED is 100 degrees. Measure of angle BAD, so we're looking for this angle right here. It's going to be half of the arc, so half of 130 degrees, and that is 65 degrees. Our next example here, we have a circle, we have lots of arcs, and we have that GHJ right here is 42 degrees. And we're asked to find GIJ. Well, what happens is, if we know that angle GHJ is 42, that means the arc that connects G to J is 2 times 42, or 84 degrees. We also notice that this angle I, GIJ, also creates the same arc. So the angle of GIJ is half of 84 degrees, which is also 42 degrees. What do we notice? We notice they have the same measure. Name the two pairs of congruent angles and find their measures. So we have here, we know that this angle and that angle are going to be congruent because they go to the same arc. Two angles that go to the same arc are going to be congruent. So we're going to say that angle MOL is congruent to angle MNL, and that they both are equal to 38 degrees. We also have this arc is shared between this angle and that angle. So we will say that angle NMO is congruent to angle NLO, and that they are equal to half of 88 or 44 degrees. Inscribed polygon. Inscribed means inside, so this is when a polygon is inside of a circle. There's basically two that we're going to be looking at. That is the triangle and the quadrilateral. And we talked about this before when dealing with triangles. The circle is called the circumscribed circle. One of the theorems in this section, if one side of an inscribed triangle is a diameter, then the triangle is a right triangle. And it makes sense. We have a diameter, which is 180 degrees, and we know from our work with inscribed angles that this angle would be half of 180 or 90 degrees. So this theorem is just simply stating what we have been seeing. Next theorem, a quad can be inscribed if and only if, remember IFF stands for if and only if, the opposite angles are supplementary. So we'd have here that angle N and angle O are supplementary. As well as the measure of angle L plus the measure of angle M also equals 180 degrees. All right, two last examples. Find the value of each variable. Again, we know the opposite angles are supplementary. So we know that 4x plus 100 equals 180, as well as 2y plus 60, and then we just need to solve each of these. And again, no degree markers because we're solving for a variable, and the fact that the degree marker is there already. One more example. And we see here that 7x plus 5x equals 180, and we'll solve that. As well as with the y's. And we find that x equals 15 and y equals 5. This section is pretty straightforward, just a matter of making sure you show your work and your setup and solving each of these.